Welcome user. In the last video, we have seen how can an algorithm work. In this video, we are going to solve classification problem by using Naïve based algorithm. First, let us see how Naïve based algorithm works, and in the next video, we will see implementation of Naïve based algorithm in the MATLAB. So let's get started. To understand Naïve based algorithm, consider popular example that we all times see while solving questions on probability. The question is, if we pick a random card, what is probability of getting king? There are total 4 kings and 52 total cards. Then we can say the probability of getting king is 4 by 52. Let us see one more example. Pick a random card, you know it is diamond. Now what is the probability of getting king? This problem is called as a conditional probability, where you know the event is already happened. So the answer is 1 by 13, where 13 are the diamond cards. This is how the conditional probability is represented. Thomas Bayes gave the famous equation of finding a conditional probability. Probability of A slash B, where B event has already happened, is equal to product of probability of A and probability of B slash A, where A event is already happened, whole divided by probability of B. So above example also we can solve by using Bayes formula. Over here you can see how we can solve discussed problem with the help of Bayes formula. So we can conclude from the above discussion that by knowing the probability of certain events, we can find the probability of other events. Let us consider one example where we will get more idea about the Naïve Bayes theorem. Suppose we are having n number of features, and for those features we are having y as an output label. So the question is how we can calculate event y for these multiple x features. We have discussed Bayes theorem gives probability of A slash B, where B event has already happened. If you notice over here we have only one event, but in the above case we have multiple events. So how we can solve this problem? We can solve this problem by considering one assumption called as a naive assumption. According to naive assumption, we can say all events of input features are not dependent on each other. So right here you can see the Bayes formula has a naive assumption. Now solve one problem statement. Let us discuss one common example. So below data will predict the event yes or no based on the features, outlook and temperature. So in this problem we can say by knowing weather condition and temperature of the day, we can predict whether the cricket match will happen or not. In the problem we have total 3 features. Out of 3 features, outlook and temperatures are the independent features and play is the dependent features. So we can predict the play event by looking into the independent events, those are already happened. Right here you can see frequency table of each featured based on the play event. By looking into the outlook feature, we can say factor level of outlook feature is 3. For the temperature feature, factor level is 3, and for the play feature, factor level is 2. So I have calculated the probability of each factor level for yes and no label. Now suppose we want to calculate probability of match will happen or not for today has the sunny outlook and hot temperature. Right here you can see derived equation for the discussed problem. The equation will calculate the probability of yes for the sunny and hot events, where sunny and hot events are independent and events are already happened, is equal to product of probability of sunny slash yes, where yes is already happened, and probability of hot slash yes, where yes is already happened, and probability of yes, whole divided by probability of hot and probability of sunny. Same formula we have derived for the probability of no for the sunny and hot events, where sunny and hot events are already happened. Right here you can see the mathematical forms. Now fill the probabilities by looking into discussed frequency table. Right here you can see after calculation we will get these values. Now normalize each probability. And now you can see probability of no is more than probability of yes for the same events. And we can say for the today has the event sunny and hot, the match will not happen. This is all about Naïve Bayes algorithm. This will end our video. In this video we have completed theoretical part of Naïve Bayes theorem. In the next video we will see how we can implement the same algorithm in the MATLAB and in the classification learner app. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future. MATLAB is our feature. Happy MATLABing.